Hi, so today I want to show you the latest and greatest improvement on the project here. So we're back to the breadboard today. And what I've done is we've connected the hardware interrupts to our V30 here. So let me just demonstrate it working real quick. So we're going to open the application here. And as you can see, up in the top right hand corner there, it says IO8, interrupt 8, and it's incrementing that character there at the end. So that's interrupt request 0. And we can actually map them wherever we want. I'm going to push some keys here on the keyboard. You can see IO9 and it's incrementing the value there. So right now my interrupt handler does not handle the keyboard. It still is being handled by the Raspberry Pi. I just wanted to get this demo out there. But let me show you how the code works basically. So here's the interrupt 9 code real quick. It just sets to the video memory here. 138 is kind of towards the end of the screen there. Prints I09 and then it increments that byte there. Interrupt 8's the same deal. It just does a little bit further out on the screen. So the timer, what the timer is currently doing, as you can see, it's the old code where the Raspberry Pi is going to update the memory timer tick right now. We're going to take that out and we're going to change the interrupt 8 code to do the timer tick, not the Raspberry Pi. But so then basically it'll be a delay here and then IRQ0, delay IRQ0. And then eventually what you do is just like your programmable interrupt or the timer, the programmable timer that they have on the boards, we map the I/O port so that it functions more like the timer, so you can like set the delay. Let me show you the. So right now you can see this is the keyboard handler. It still handles it the old way, but all this code will be gone, and it'll be just handled by the 8088. So right now the way it's working is we're gonna port 60 there, right IO byte 60, port 60. We're sending the scan code out, and that's IRQ1, which is interrupt 9. You typically map your IRQ 0 to 8, and then 1 to 9, and kind of up from there. Right now I only handle the 2, but we could actually we can make every interrupt a hardware interrupt in this system. There is no limitation. It's just how much code you want to write. For the processor, let me show you the 8088. It's a little bit more simpler. So if it's the processor 88, you got your read memory, write IO, read IO, and then your interrupts right here. So the control bus is different on this one. The last one, the control bus, read the IO mem pin, the read pin, and the write pin. Well, we've changed that. Let me just kind of click up here. We're now reading the direction pin, the IO mem pin, and the interrupt acknowledge pin. So the direction pin is going to tell if it's a read or a write, which this all comes back to why we didn't do this in the first place, was because the lack of pins. I mean, we've maxed it out. We've used every pin that's available on the Raspberry Pi to make this work. And my concern was the only way we could get more pins was giving up memory space, so it'd be like a 512 memory instead of 1 meg. But I was able to do this by using the pin DTR. It gave us an extra pin. So the DTR is your read-write, and then your IO mem tells you what it is, and then your interrupt acknowledge. So let's just scroll back down here. So down here in the interrupt section, when an interrupt acknowledge happens, the address latch still actually triggers. I'm not sure why that is, but it indicates the beginning of a bus cycle. But for the interrupt acknowledge, there's 2 bus cycles, and it's because of the lock, like the bus lock on maximum mode. So we are going to do 4 clocks just to go into the second acknowledge, because that's when it actually asks for the pointer. And we come down here, and we're going to read the interrupts. This little command here, read interrupts. It's pretty straightforward. It just takes the IRQ0 flag, the IRQ1 flag, and it returns it as a character or a byte. Up here you've got your IRQ flag 1, IRQ flag 0. And when you call that function, if you remember here the function IRQ0, what it does is it sets that as a true, and it requests, the pin interrupt request goes high. Really straightforward. So if you wanted to do a 2, you just copy and paste this and make it IRQ2, add an IRQ2 flag, and then add it down here to read interrupts, add in 2. Like I said, you could add in 50 of these things. It doesn't matter. It just depends on how long you want your code. So that's your interrupt functions. So we're going to come back down here and just look at this. Like I said, the 8088 is just a little bit cleaner because it's just shorter. You don't have the bank high and bank low. So we come in here at case 1, which is IRQ 0. It's going to set the pointer 8. You could change this to 0, you could change this to 1, but that's the interrupt that's going to be called. Then we're going to click twice, just like we do on bus cycles, and that gives the processor the time, like up here on a bus cycle, you see 2 clicks, 2 clicks. So the reading the pointer's like a typical bus cycle. Then you've got your case 2, which is interrupt 9, or IRQ1, interrupt 9. You can see there, 9. So if you were to add an interrupt 2, it would be case 4, because it's binary. Now, we got case 3. This means both were called. Now, this is where you set your priorities. I'm telling it 8 is the priority. And what happens, as you can see, let's go through 2 real quick. You go direction out, puts a 9 out there, clicks twice, direction in, and it sets the flag to false, saying that it's no longer needing attention. And we digital write the interrupt request line to low. So this is like an auto end interrupt. Keep in mind, this is not your 8259 controller. This is a software controller. So that sets it to low, meaning there's no more interrupts that need to be handled, where the 3, if you look here, it does the IRQ 0 to false because we address 8, which is IRQ 0, first. We set that as a higher priority. But I leave the interrupt pin high so that it knows there's still another interrupt that needs to be handled. So if you're going to add your second interrupt, or your IRQ2, you'd be case 4, but then you'd also have to have case 5, 6, and 7 to handle which ones are called, and you can set your priorities, if that makes sense. Right here, I just got my default. It just says default interrupt. It's kind of like for debugging, tells you that it called an interrupt whatever, and it just didn't. If you get this, there's an error. And so that's on the V20. Let me show you the V30. It's pretty much identical. It's not like it reads 16 bits for the interrupt pointer. It still reads only 8. So here's the read interrupts. I label them sister timer, keyboard. And you can see it's identical. For handling the interrupts, that is. Bus cycles are obviously different. Now, here's something though. Because it goes to the second bus cycle for the interrupt acknowledge, we do 7 clicks on the V30. I'm not sure why it's 7 clicks, but that's what it counted out to. I had to kind of debug it and manually figure this one out. But 7 clicks is what it wants before it starts the interrupt acknowledge. You would think it'd be like 4 or 8, some sort of round number like that, but it's not. It's 7. So there's the code on that. If you have any questions, you can email me. We're gonna get a PCB made, just like it's gonna be identical to the current PCB, except for it's going to remap our pins for the interrupt acknowledge, the interrupt request, and then as you can see, we're looking at, you can see, so you got your preset, interrupt acknowledge, address latch, DTR, IO, mem, and then pin 34 is for your bank high, and that's only for the V30. So then all your address pins, and then your clock, and your interrupt request. So let's see if we crashed it by touching it, but no, it's still running. I've left this running for hours, and it hasn't crashed, so it's pretty reliable. So now you might say, why do we need interrupts if we didn't have them before? Well, there's certain software that'll remap your interrupt, like your keyboard interrupt, like in games. It'll remap your keyboard interrupt for the game. And it wants a hardware interrupt. It doesn't handle a software interrupt. Mostly games. I haven't seen any major applications that do that. But it's kind of nice to just get those working the way they're supposed to work. So, thanks for checking this out.